By the end of this video, you will be able to describe what the process of elastic rebound is and what happens before and during an earthquake. You will be able to define what strain and elastic behavior are, and you will be able to explain how the dowel and rubber band are analogs for elastic rebound.
Okay, so today we're here to demonstrate what happens during an earthquake. We have Christian and Brian here to help me do that. And you're probably thinking, well, I know what happens during an earthquake. You probably have an image in your head, in your mind about what happens. The earth shakes, like, oh my gosh, not quite. Yes, that's true. Maybe you're thinking buildings collapse or bridges and roads, highways come crashing down. There's plenty of destruction and unfortunate things that happen. But today we want to demonstrate what's actually happening in the earth when there is an earthquake. What's actually happening to the rocks inside the crust, the lithosphere, when leading up to and during an earthquake. So earthquakes happen. They occur on a feature in Earth's crust or lithosphere called a fault. A fault is a break or a fracture in Earth's crust. Some faults move vertically up and down, and some move horizontally or laterally side by side. But the rocks along both sides of a fault do move. They experience a lot of stress, a lot of forces are acting on them that are acting over big regions, great distances, mainly due to the fact that Earth's tectonic plates are constantly in motion. And so these forces that are acting as these tectonic plates are moving around extend over hundreds and thousands of miles. So the forces, the earthquakes, aren't just occurring at plate boundaries, they could occur within plates as well. And so a fault doesn't just exist on a plate boundary. We know that they exist, many of them exist within plates. And so these forces are extending within plates as well. And so we want to demonstrate what happens to layers of rock along a fault and what happens as they experience this stress. And so we have these wooden dowels. They're made of wood. They're nice and straight, right? Nice and straight, guys. And so we're going to use these as an analogy to layers of rock in the crust. These are layers of rock. Somewhere in here is a fault plane. We can't see it, but we know that there is a fault in there along which movement would occur or will occur as we start to enact out what's happening during an earthquake. So these are just like the rocks of our crust. These are our analogy here. We want to apply some stress to our dowel, just like the rocks in the crust experience stress on a regular basis. So let's apply a little stress, a little bit, aha. So what's happened to our wooden dowels? What happened?
Looks like they've become a little deformed.
Deformed?
I'd say a little bent.
Little bent, deformed, absolutely. And rocks change their shape just like our wooden dowel has changed its shape along both sides of a fault. When a rock changes its shape, or our wooden dowels in this case have changed their shape, we say it's strained. To strain something means to change its shape. Now that's a word you probably already know, strain, because I'll bet you both have strained a muscle somewhere playing
football sports.
Playing
tennis.
Tennis, yeah. I don't strain, no, I'm only kidding. I do have strained muscles, so maybe your ankle, your wrist, your back. When you get older, your neck and back start to go. So yeah, strain means to change shape, and our dowel definitely has deformed or changed shape. And that's the reason why a strained muscle hurts so much, is because it's changed shape. It's not its normal shape anymore. So we can deform that just like that. Now there's another instrument or tool besides a dowel that can also change its shape. I have this in my pocket now. Aha, what do we have here?
Looks like a rubber band.
Rubber band, yeah. So we also call these elastic bands, and that's an important word, elastic, the elasticity. Elastic behavior, yeah, we can release those for a little while. Elastic behavior means that we can apply a stress to our rubber band from its original shape, and we can see that the rubber band is definitely changed its original shape. It's definitely deformed. But once I release that stress, back to its original shape. And that's what elastic behavior does. So we can deform it, we can strain the elastic band, and in this case, I release the stress and our rubber band really took a flight. It's in a different location, but that happens too with rocks along a fault. Once that stress is released from those rocks do move and they're not in the same position. So very much like the rubber band. So we're going to go back to our dowels again, and we're going to apply some stress to it. We want to strain it and keep on straining, and dare I say there's 1, there's 2, and there's 3. So our dowels have reached their elastic limit. And when they reach their elastic limit, when rocks reach their elastic limit, that's when we get that slip along the fault. In this case, what had happened when it broke? Did you hear anything?
I heard some sound.
You heard a sound. So sound is energy. It travels in the form of a wave that we are able to hear. Earthquakes, when that stress is released, after those rocks hit their elastic limit, energy is released in the form of waves, and we're going to demonstrate that too. So let's do this once more. So we have our rocks. They are undeformed at this point. We apply a stress. They strain, they change their shape. They reach an elastic limit, and our fault, or our dowel breaks, and we hear a sound. Sound energy is released in the form of sound waves. With rocks, they are in a different position, but they go back to being undeformed. They rebound to being undeformed, just like our rubber band. I have another one. Strains, is deformed, and rebounds to its original shape. Rebound, where does that word come from? What sport?
Definitely from basketball.
Basketball, yes. Both our 2 middle school basketball players know all about rebounding. And so what happens to rocks during an earthquake, before and during an earthquake, we say is elastic rebound. Because the rocks, just like our wooden dowel, our rubber band, behave elastically. And once that stress is released, they rebound to being undeformed. So even though our dowels break, they're straight wooden dowels again. Once we release our rubber band, our elastic band, I'm not going to hit you, it goes back being to undeformed. So remember, the bending, the stress is applied, we have a bending, and eventually it snaps. So here's our version of the bend and snap. Apply a stress, the rock strains, there's slip along the fault once that rock reaches its elastic limit, but it goes back to being undeformed. It may have moved along the fault. It's in a different location, just like our wood is in a different location, our rubber band went flying, but it's rebounded to being undeformed. And then the process just continues as new forces and new stress is applied to those rocks, and eventually we may get another earthquake. So bend and snap, elastic rebound, this is what's happening to the rocks in the crust lithosphere before and during an earthquake.